All right, so for this question, they want us to find out a probability here, given that 2 of the 246. Now I'm going to circle that. That's going to be helpful to us to realize up here in the instruction that they've told us that these numbers, these 8 numbers, add up to 246. It'll save us some time. We're going to say, what's the probability that 2 of these selected subjects are both group A and type RH plus? All right, so just so you know, this is blood types. This is rhesus here. That's what RH stands for. So everybody is either O positive or O negative, A positive or A negative, and so on and so forth. And so when we say they're group A and they're type RH plus, this is basically the RH. These are people that are A positive blood type. So there's 65 people that are A positive blood type. Now, another thing that's in this question that's very important we need to notice, assume the selections are made with replacement. This means like I'm going to pull the name out of a hat, and then I'm going to put the name back in the hat, and I'm going to pull the name again. So if I put the name in the hat, back in the hat, I can pull that same name right back out, right? So that's the difference. If I pull a name out of a hat and it's no longer in the hat, then that changes the mathematics a little bit. I think that's probably what part B is going to ask us to do. So if I go pull out a name out of the hat, the very first one is I have 65 out of, and this is where that recognizing that 246 is up there saves us a little bit of time. 65 out of these 246 people have A positive blood type. All right, so when I put the name back in the hat, then when I go to multiply here, the next time, since the name's back in the hat, I still have a 65 out of 246 chance, and that's the probability of getting 2 names that are RH positive. So we're going to take out our regular old basic calculator, and so I'm going to type 65 times 65 times 65 divided by 246 divided by 246, and we get 0.0698. Now it wants us to go to 4 decimal places here, so let's make sure we go to 4, so 0.0698, and then the 5th decimal place is 1. 1 says round down or keep it the same, so 0.0698. 0.0698 is my number. All right. Now part B says, now assume the selections are made, and here's the key difference here with part B. Assume the selections are made without replacement. All right, notice up here it said with replacement. Now it says without. All right, so that's the difference. So now we're going to pull the name out of the hat, but we're not going to put it back in. So the first name we pull out of the hat, we have a 65 out of 246 chance that that person is A positive. Now, if the name is no longer, if you've taken it out of the hat, now we don't have 246 names in the hat anymore. We only have 245 names left in the hat. And in fact, if we pulled out an A positive person, there's one less of them as well. So the chances of finding another A positive is now 64. All right, and this is what we call conditional probability. Conditional, meaning that whatever happened the first time has an impact on what happens the second time. So a coin flip is not conditional. Like a coin flip, if you get heads, there's nothing that says that's going to reduce your chances of getting heads the next time. It's still a 50-50 chance every time to get heads, or to roll a 6 on a dice, or to do whatever it is. So all those things are not conditional, but conditional means like pulling cards out of a deck of cards. If you pull the 3 of hearts out of a deck of cards, now there's only 51 cards in the deck, and there's one less heart, there's one less 3, and so then the chances of getting another 3 are made more difficult, and poker players realize this because getting 4 of a kind is extremely difficult because you're looking for all those 3s, and every time a 3 comes out of the deck, there's less of them there, and the more difficult it is to get that specific card. So anyway, this is what we do here for this one. So let me get the calculator back out. We'll see the probability is a little bit less now. All right, so 65 divided by 246 times 64 divided by 245. And now this time, see, the number is really close, but it does drop a little bit. At 4 decimal places, it's 0.6902. The 2 is less than a 5, so means we just throw all those numbers away and we get 0.690. 0.0690. So that's the difference between these two. This part B is called conditional probability, and so anytime the outcome of one event has an impact on later events, then we call that conditional, and we have to do this kind of math.